So I had a couple of students who needed some additional clarification on what we did this week, and so I wanted to do another video, and I'm just going to do one example, but I'm going to kind of tie everything in together, so hopefully it makes it a little bit clearer. And then if you need a little bit more, we can do another example like this. But remember, we're dealing with quadratics here, and so a quadratic is written in the form ax squared plus bx plus c, and when we graph a quadratic, it makes a parabola. So it either opens up or it opens down, okay? And based on the notes that we took, we know that in order for it to open up, this a value has to be positive, okay? If we want it to open down, then that a value will need to be negative, all right? And so that lets us know which direction our parabola is going to open. Okay, so there's a lot of different information that that we talked about this week, and so we're just going to take it step by step. So a parabola, we know, has an axis of symmetry, which means that it is identical on the left side as it is from the right side down this center line. So we need to find what the axis of symmetry is on our parabola in order to graph our parabola. Okay, so the axis of symmetry, there is a formula for it. It's x equals negative b divided by 2a. So here is our equation that we're dealing with. Y equals 2x squared minus 4 minus 3. So our a value is right here. It's 2. Our b value here is negative 4. And our c value here is negative 3. So we're going to take that information and plug it into this equation, x equals negative b divided by 2a, to find our axis of symmetry. So negative, b is a negative 4, and then 2 multiplied by a, which is 2. So negative 4 times a negative 1 is a positive 4. 2 times 2 is a positive 4, which is equal to 1. Okay, so our axis of symmetry is x equals 1. And here is what that means. That means that there is a vertical line at x equals 1. So here's our graph. Okay, what that means is that x equals 1, apologize for having to clear my throat, x equals 1, that no matter what y value we have, the x value is going to be 1. So 1, 0 is a point on this line. 1, 1 is a point on this line. 1, negative 1 is a point on this line. But no matter what, the x value is 1, which is going to create a vertical line. And I know it's not real easy to see that vertical line here, but I don't want it to be because it's not our primary focus. The primary focus for our graph is going to be our parabola. But you can see there is an invisible line here that is our axis of symmetry. Okay? So, if that is our axis of symmetry for the quadratic, for the parabola, in order for things to be equal on the left side as they are on the right side, then there has to be a turning point where our parabola changes directions, either starts going from down to up, or if starts going from up to down, but there has to be a turning point. So in order to find the turning point, we know that it has to be on the axis of symmetry, so that we know that the x-axis, or the x value, has to be 1. So if x is equal to 1, if I want to know what y is, I have to plug it into this original equation. So y is equal to 2x squared minus 4x minus 3. Well, if I know what x is, in this case I want it to be 1 because our vertex, our point, has to be on that line, I'm going to take the 1 value and plug it in. So y is equal to 2 multiplied by 1 squared minus 4 times 1 minus 3. Okay, so all I did was take that 1, that value of x, and plug it in every time I saw x here. And then I'm just going to simplify that. So y is equal to 1 squared is 1, so 2 times 1 minus 4 times 1 minus 3. Okay, we're doing order of operations here. So I did my exponents, now I move to my multiplication. 2 minus 4 minus 3, and now we subtract. 2 minus 4 is negative 2, minus 3 is negative 5. Okay, so in this case, our y value is negative 5. So if x is 1 and y is negative 5, okay, then that is our vertex. Okay, and the vertex is our turning point. So we're going to find it on our graph here. So 1, -5, 1, 2, 3, 4, 5 is right here. That is the turning point. Okay, so our parabola is either going to go in this direction or it's going to go in this direction. Okay, and based on the information that we have, 2 is positive. So if it's positive, that means it's going to be opening up, okay, like a smile. All right. Now, if we want to graph this, we have to come up with some other points other than just the vertex. So I'm going to take and make me an XY table because that seems to be the easiest thing to do. And I'm going to use 5 different numbers here. Okay, because 5 points is usually a pretty good indicator of where we're at on our graph, and we can get a pretty good visual of it by that point. So we start with our vertex and we put it in the middle because it is our middle point. Okay, then we're going to want to go 2 points above that and 2 points below that. Okay, so here's our x value of 1. I want to go to the left, which is 0, and -1. So I'm going to do 0 and -1. And then I want to go to the right. Here's 1, I want to go 2 and 3, okay? And then all I have to do is find the y value that corresponds with that. So for every one of these, I'm going to take that x value, plug it into that equation, and find out what y is, okay? So for the first one, -1, y is equal to 2 times -1 squared minus 4 times -1 minus 3, okay? And we can work that out. So y is going to be equal to -1 times -1 is 1, so 2 plus 4 minus 3. Okay, it's a plus 4 because -4 times -1 is a positive 4. And then we can add that together. So 2 plus 4 is 6 minus 3 is 3. So here we end up with -1, 3. That's one of the points that we can plot on our graph. So -1, 1, -1, 1, 2, 3. Okay, so there's a point on our graph. All right, now 0. If I plug in 0, y equals 2, 0 squared minus 4 times 0 minus 3. Oops. We end up with 0 times 0 is 0, times 2 is 0, -4 times 0 is 0, minus 3. So we end up with 0 minus 0 is 0, minus 3, which is -3. So here in this case, we would have a -3 as our y value. So again, we plot it. Here's 0 and our x, and here is -3. So that's where our next point goes. Okay, we have our vertex, it's 1, -5, and then we go to 2. So y equals 2, and instead of x, again, we're going to use 2 squared minus 4. We're going to plug in 2 there, minus 3. And we're just going to multiply that out. 2 times 2 is 4, times 2 is 8. -4 times 2 is -8. And we end up with 8. Minus 8 is 0, minus 3 is -3. So here again we have -3, which should be the case because one direction to the left we moved 2 points up. Here, one direction to the right, we're also going to move 2 points up. So that makes sense. We should have a -3 there. All right, and then the last one we're going to do is this 3 value. So 2 times 3 squared minus 4 times 3 minus 3. And 3 times 3 is 9, times 2 is 18. -4 times 3 is -12, minus 3. So 18 minus 12 is 6 minus 3, which is 3. Okay, which is what we had for the -1. So they're the same distance away from the vertex, so they should have the same y value. So we're going to go ahead and plot those points. So 2, -3, 1, 2, 1, 2, 3, here's that point. 3, 3, 1, 2, 3, 1, 2, 3, there's that point. Okay, so now I have enough points to see kind of the direction that my graph is going. So I can go ahead and just kind of make my graph just like that. Okay? All right, so now I know what my graph looks like. Now, here's where we get into solutions. Now, if you are solving a quadratic or you're solving a linear equation, you're looking for the point where the line crosses the x-axis. Well, in this case, we're going to notice that your line is going to cross the x-axis in two places. Now, my numbers are not exact because my graph is not exact, but somewhere in this region, you're going to have two solutions or zeros or roots or whatever you want to call them, but it's basically your x-intercepts. I have two x-intercepts, okay? And one of the things that we talked about was this discriminant value. And a discriminant just tells us how many solutions we're supposed to have. And so if you look back at your notes, we would plug in these values. So b squared, that's negative 4 squared minus 4. A is 2 and C is negative 3. So negative 4 times negative 4 is 16. And then negative 4 times 2 is negative 8. Negative 8 times negative 3 is going to be a positive 24. Make sure I got my math correct. We're going to plug it into our calculator. It's 2 times negative 3. Okay, and we end up, excuse me, with a positive 40. And if you remember your instructions, if you had a positive number, okay, or the discriminant was greater than 0, okay, so a positive number, then it means that you had two solutions to this. And when we graphed it, we see that, yeah, we do have two x-intercepts, okay? But now we need to find those x-intercepts. And that's something that we can do using a couple of different methods that we're going to learn about next week. Okay, but for this week, you just know that you do have two solutions, and they are these 2 points. Now, I don't know exactly what those 2 points are, but I could find them if I wanted to, and that's what we're going to be talking about next week. But these are your two x-intercepts. Okay, so this is all the information that we covered last week. Basically just a broad overview of what a quadratic is, and also some information just about how to find it, how to graph it, what a solution even looks like. And if it were to work out that we had 0 here as one of our one of our y values, then we would know what the x-intercepts are. In this case, it's not going to be a whole number, so we would have to do some mathematical calculations to find our solution, which we're not going to get into until next week. That's something that we'll talk about then. Hopefully this clears it up. If you need another example, I'll be glad to do another example. I can even show you an example where there's only one solution or an example where there are no solutions. Just let me know what you need and I'll be glad to do that. But hope this helps.